Hello everyone, my name is Josh and I am going to teach you Ohm's law. It's a very simple and a very useful law. It was found by the man called George Simon Ohm. That's not three different people, that is one guy, and he discovered the law in 1825. That is a really old law then, right? So why is it important? What is so useful about it? Why are we talking about it some roughly 200 years afterwards? So the Ohm's law is a really nice and elegant relation between two quantities. One quantity is called voltage, which is represented by the symbol V, and another quantity is called current, which is represented by the symbol I. So in order to understand the Ohm's law, we should first get an idea of what is current and what is voltage. So let us look at current first, and we have current as basically the flow of charge. It is how much flow of charge is occurring in how much time. So we can have it in two ways. One, we could have a positive charge which is going in one direction, or we could have also a negative charge which is going in the opposite direction. And these two are the same thing, right? Positive going towards the right is the same thing as negative going towards the left. So in both cases we say that current is going to the right. That is, we always take the positive direction, positive charge's direction to be the direction of the current. So we understand that if a charge were going in a direction, we have current. So we understand current. Current is a fairly intuitive thing to know. But how do we also talk about voltage? And what voltage means? So when we talk about voltage, we talk about the difference in potential between 2 points. Let us not go into what we mean by potential, but let us look at 2 points. Let's call one point P, which is here, and there is another point N, which is here. And let us say that the voltage of P, the potential at P, which I'll call Vp, is greater than Vn. That is the potential at N, right? So what happens is that if I placed a charge here, a positive charge, it is going to go to the lower potential place. And this is how positive charge is. If you take a positive charge and you keep it at a place and it finds a connection to a lower potential place, it will just drop off and go off to that lower potential place. But what happens is this: if I placed a battery in this region, so instead of this empty space, I am going to place a battery. And now the battery's positive terminal, which is what we are calling P, is at a higher potential than the negative terminal. So expectedly, if I put a charge here, it should be able to go down, but it can't. And this is because a battery is such that inside the battery there are chemical forces which push positive charge upwards. So if I place a positive charge here, a battery is going to kick it up and take it there. So your positive charge, because of the battery, it can't go from a higher potential to, that is a P to N. But we had seen earlier that our positive charge would like to do this. So if we connected the positive terminal to the negative terminal by means of a wire, right, what will happen? Your positive charge will now start going through this wire and reach the negative terminal. And we have already talked about how the battery, once you get a positive charge to negative terminal, will kick it up to the positive terminal through chemical forces inside. And once your charge reaches here again, it is again going to go around and come down. This is a lot like what you would expect in a water pump. So what happens in a water pump is you have water flowing down on a slope surface, suppose. So this water is flowing and it is reaching here. And since this is the same height, I can make it move like this. And now suppose again I'm going to call this point N and this point P, but what I am placing here is a pump. And what this pump does is it takes this water from this region and it conveys this water up. This is what a pump does, right? It takes water from the ground floor and takes it to a higher place. And now once the water is here, it is again going to fall down the slope and then again going to reach this point because it's on the same horizontal level, and the pump is again going to pull this water up and bring it here, which is what we are kind of seeing even in the voltage case, right? Here the charge is like water. And the battery is like a pump. And in this case, the voltage then is like height. The more the height, the more the water will want to fall down. The more work needs to be done in order to pull this water from the ground level to the top level. That means in this case, the more work needs to be done to pull the positive charge from the negative terminal to the positive terminal. And that work that is required to pull the charge is what we call voltage. So I hope you understood what voltage is. You also understood what current is. And now we have to come to the question of what did Ohm discover at the end of it all? What is the relation between these two quantities? And that relation, what Ohm discovered, is this. The voltage is proportional to the current. And what does that mean? That means if the voltage were to increase, the current would also increase those many times. If the voltage were to become twice, the current would also become twice. If the voltage were to become half, the current would also become half. So when V is proportional to I, I can resolve this proportionality. I can make this an equation and write it as V is equal to I into some constant. This is some number which relates V and I. And what is this number in an electrical circuit is, this is what we call the resistance of wire. So in the circuit, if I have to redraw the circuit, now this looks quite ugly. So let us go to a new circuit diagram, and I'm going to represent the battery with this symbol, and I'm going to place a resistance like this. And now we have current flowing from the positive terminal to the negative terminal. It goes around, goes around, goes around, goes around, goes around, and then it comes to the negative terminal. And here we have the resistance R, and the difference in potential here is the V. So V is equal to IR, right? So what I want you to understand is, if now V is fixed, that is our battery is fixed, and I'm increasing R, then our I should decrease clearly, right? Because I will become V by R. So more the resistance of the wire, lesser the current in the circuit. Let us now look at this as a simulation. Now here in this simulation, we see that this is a battery, and if you can look at this, you see that this is the positive terminal and this is the negative terminal of the battery. If we went closer, we see this is the resistance of the wire. This white plank is not a realistic thing. The white plank is just there for our convenience of understanding how charge flows. So right now there is no voltage, the battery is at 0 voltage, and if I increased this, I start seeing the charge is flowing, right? We have the charge going from the positive to the negative terminal, and we have seen that the height has increased. Let us again increase the voltage further on, and you see that the height is increased. This height is just an analogy so that you can remember the water analogy. Here you can see that the positive charge is flowing as though it is water from a height, right? It is falling through the slope and going around, and the battery is pushing it from below to above. So it's going in here and the battery is pushing it up, and the charge is turning around and coming this way, right? But this is not what really happens. What really happens is electrons move. It isn't the positive charge. So what really happens is this: the negative charge goes from the negative terminal around, goes up the resistance, turns and comes to the positive terminal, and the battery pushes this negative charge down to the negative terminal. So this is what really happens. And if you look at the resistance, this is made to now look like the slope along which the water is rolling down, whereas the battery is seen as the pump which is taking this water up the height. And when you look at it in terms of electrons, we see that it is happening in the opposite direction. In both cases, the current is taken to be going from the positive terminal to the negative terminal along the resistance. Now let us verify what happens with the current. The voltage is right now 13 volts, and if we went to the resistance we will see it is 5. I could increase the resistance to say, let us say make it 13 as well, and now this current, what is the value? 1 amp. We see that the current is 1 ampere, and this is exactly what we expect because current is V by R according to Ohm's law. Now suppose we change this to something else. Let us say I made it 7 volt, and then let us say I also made the resistance to 14 ohm, in which case the current is 0.5 amp as is expected because we have 7 by 14, which is half. So with this simulation we could see that the current actually changes according to the Ohm's law. If I change this further till 28, because the voltage is 7 volt and the resistance is 28 ohm, we see that the current is 0.25